All right, let's dive right into this explainer. If you've spent any time at all building machine learning models, you know exactly what it feels like to hit that run button on your training loop. It's kind of like launching a probe into deep space, right? You wait, you hope, and you practically pray it comes back with good results. But what if you didn't have to just hope? What if you could have absolute visibility and control while that model is training? Well, today, we're figuring out exactly how Keras Callbacks manage training to give you that ultimate control. To really grasp why callbacks are built the way they are, we've got to start with this core ethos. Keras is an API designed for human beings, not machines. It's not just a catchy marketing tagline, I promise. It's literally the foundational design philosophy of the whole framework. The primary focus here? Developer experience. It's built from the ground up to maximize your debugging speed, keep your code elegant, and frankly, just make your life as an ML practitioner a whole lot easier. So, here's our roadmap for today. We're going to cover 1. Deep learning for humans, 2. Inside the training pipeline, 3. Enter the Callbacks API, 4. Built-in training supervisors, 5. Customizing the fit loop, and finally, 6. Powering the Keras ecosystem. Let's get to it.
All right, Section 1, Deep Learning for Humans.
When you choose Keras, you're explicitly opting for a framework that actively keeps your code base smaller and way more readable. It focuses heavily on debugging speed and code conciseness. And honestly, this is absolutely crucial. Because in the real world, you spend just a tiny fraction of your time writing the initial model and the vast majority of your time tuning it, debugging it, and maintaining it. By simplifying deployability, Keras lets you focus on the actual architecture, not all that boring boilerplate.
Moving right along, Section 2. Inside the training pipeline. Now, think about a standard ML pipeline. You've got your data pre-processing, feature engineering, model validation, deployment, the whole shebang. But right smack in the middle, you have this phase where you're actually training models. And this phase, it can feel completely locked in. Once you trigger it, especially on those massive datasets, it might run for hours or even days. Without the right tools, you have absolutely zero insight into what the model is doing internally until the very end. I mean, if a model's loss explodes early on, you won't even know until you've already wasted all that precious compute time. Which brings us to Section 3, Enter the Callbacks API. So how do we fix that blind spot? That's where the Callbacks API comes in. By definition, a callback is simply an object that can perform actions at various stages of training. I like to think of them as your inside agents or, your training supervisors. While you step away to grab a coffee, these callbacks stay behind. They report back on metrics and automatically take action based on the exact rules you set up. This API is amazing because it gives you hooks into practically every microstep of the model's learning journey. You can inject logic right at the start of training, at the start of a branding epoch, right before or after a single batch of data is processed, and, of course, at the end of an epoch. It's giving you incredibly granular control over the entire temporal flow of your model's optimization.
Okay, Section 4, Built-in training supervisors.
Out of the box, Keras provides these specific callbacks that honestly give you immediate superpowers. Take EarlyStopping, for example. This is a massive time and money saver. It monitors your metrics, and if your model stops improving, it literally just halts the training automatically, saving you tons of expensive compute. Then there's ModelCheckpoint. That's your safety net. It periodically saves your model's progress straight to disk, so you never lose hours of training to some random setting crash. And TensorBoard? That rates out logs after every single batch, giving you a beautiful visual window into those internal model statistics. Let's dive a bit deeper in Section 5, Customizing the fit loop. Now, you might be wondering, is it hard to set this up? Actually, it's incredibly simple to inject these agents into your codebase. Remember, Keras prioritizes code elegance. You simply package your chosen supervisors into a straightforward Python list. Take this setup, for example. We configure EarlyStopping to have a patience of 2 epochs. We set our ModelCheckpoint to dynamically name our saved files based on the actual epoch number, and we point TensorBoard to a local logging directory. It's clean, it's totally readable, and it's highly configurable. Once that list is ready, deploying these agents is an absolute breeze. You just pass this list right into the standard built-in model.fit loop using the callbacks keyword argument. And that's literally it. Keras steps in and handles all the complex orchestration for you, ensuring that the relevant methods of your callbacks are triggered at exactly those right stages of training we talked about a minute ago. But hey, what if those built-in agents just aren't cutting it for your specific use case? Well, creating new callbacks is a super simple and powerful way to completely customize your training loop. By subclassing the base callback class, you get a direct view into internal states and statistics. You can write custom routing, set up complex logging, or even make dynamic adjustments to the model itself mid-training. It basically gives you the insane flexibility of a fully custom training loop, but with the elegant simplicity of the standard fit method.
Finally, let's zoom out for Section 6, powering the Keras ecosystem.
Because Keras 3 is a true multi-backend powerhouse, mastering these callbacks gives you a ridiculous advantage. This API isn't locked down to just one system. You get seamless, multi-framework execution. So whether you're leveraging the massive TPU training infrastructure of JAX, the robust deployment tools of TensorFlow, or the huge ecosystem packages of PyTorch, your Keras callbacks manage the training flawlessly across all of them, without you having to change a single line of your callback logic. It's a real game changer.
And this API reaches across entirely different domains too. If you're using Keras Hub to fine-tune massive state-of-the-art computer vision or NLP models, or talking things like Stable Diffusion or Gemma, callbacks manage that fine-tuning. If you're tackling reinforcement learning with Keras RL, handling experience replay and agent interaction, the fit method and its callbacks still apply. Even if you're running Keras Tuner for hyperparameter search, your callbacks are right there, dynamically tracking optimization metrics. It really is your universal standard for training management.
By universally applying tools like the TensorBoard callback across all these wildly different ecosystem libraries, you can effortlessly compare runs and analyze model performance. Whether you're dealing with a classification model, a text generator, or a complex reinforcement learning agent, you get this beautiful, standardized way to track your precision, recall, and loss curves. It makes experiment tracking an absolute breeze. So we've seen how Keras puts human-centric design front and center, and exactly how the Callbacks API hands you the keys to deeply monitor, halt, and manipulate your training runs across any backend and any domain. So I want to leave you with this final thought. With that base callback class ready and waiting for your custom logic, what will you teach your training loop to do? Seriously, think about the bottlenecks in your current MLOps pipeline and how a custom inside agent could just solve them. Thanks for joining this explainer, and keep experimenting.